Alright, this is a pre-video for the Section 3.1 Rectangular Coordinate System notes. We shall now talk about some things that are going to be really important for us in going forward, some foundations for graphing. So we're going to make sure that we know some of these terminologies first. If you talk about an ordered pair, that's an x-coordinate and a y-coordinate paired together. Here they're calling it A and B to kind of be ambiguous. And A and B are both real numbers, and they each are, this A and B together give us a point in a plane. Now, this looks a lot like an open interval, and it can be confusing sometimes because you need to make sure you're not confusing ordered pairs with interval notation. So it really is paying attention to what kind of problem you're doing. Interval notation is used when you're talking about a single variable. An ordered pair is two variables and two different number lines. So it looks like this when we plot it. This is called the rectangular or Cartesian coordinate system. And we have this point in the middle that we've labeled here as the origin. That is the 0 for the x-axis, which is this horizontal one, and the 0 for the y-axis. Now when I think of plotting a point, I think of battleship essentially, or reading an atlas. You have a position on the x-axis, and you have a position on the y-axis, and you're trying to figure out where would they intersect. So it's like a set of directions. So if I wanted to plot the point 2, 5, from the origin, this says go positive 2 to the right, because that's the x-axis, and then this is positive 5, so that means we would go up 5 from there. So 1, 2, 3, 4, 5. So this would be the point 2, 5. Now the when you put the two axes together, they create 4 different regions. These are called the quadrants, and they are starting from the top right, and we go counterclockwise, and we use Roman numerals 1, 2, 3, and 4 to represent those. Something interesting about the points in each quadrant. In quadrant 1, you have positive x's, because this is to the right, and everything's up, so it's also positive y's. So you get plus plus as all of the signs for your ordered pairs. In quadrant 2, we go left for x, so that would be a negative number, but we go up for the y-axis, so that would be positive. So everything in quadrant 2 is a negative number with a positive number. Quadrant 3 is left and then down, so that's negative for x and negative for y. Quadrant 4 is right for x, so that would be positive, but down for y, which would be negative. Now this is important, especially in trig, to know the signs of the different quadrants, because that will help you be successful in that class. For us, you can really just talk yourself through where it needs to be plotted, but it is good to kind of know what quadrant it should be in. So remember, the horizontal line is the x-axis, the vertical line was the y-axis, and we've already talked about the quadrants. There are special names for the x-coordinate and y-coordinate, abscissa and ordinate. I don't usually refer to them using that, even though technically that is their name. If you go onto calculus or something like that, you would probably see directions where they use those more formal namings for the points. So every ordered pair is a point, and it has a coordinate of x and y. And we plot, remember, by just figuring out the directions. It's like following a road map. So our first example here is we're just going to plot these points and label them. When it says label, that means you put the letter, so you don't have to write the actual ordered pair, because that takes up quite a bit of room. So 0, 0 would be the origin. So I put a dot there, and I label that as A. 1, negative 1 would be right 1, down 1 from the origin. So that would be B. C is right 3, down 3. So that's C. D is left 1 because it's negative from the origin, and then up 1. And then E is left 3, up 3. Now if you notice, it did not tell me to graph or connect the line here. It just said to plot the points. If we wanted you to draw the line, because these do all fall in a line together, they would have to say something like graph the line that contains these points. So your directions are important here. So this is just a plot of the points. And it says describe the set of all points in the form A, negative A, which is what we have here. we have things that start out as a number, and the second spot is always the opposite sign of that number. See, all of our points are structured that way. If we wanted to look at this, this is actually a line, and it is a line that has a negative slope of, we haven't talked about slope specifically, but you should have in Math 100, so just to kind of remind you of that. Notice this is going down and then right. So if you know about slope, rise over run, that actually tells you what your slope is. But another way of thinking of it is just saying what's happening here. Y is always the opposite of X. So that is actually an equation that represents all possible points that could look like these. So, you know, it's just, we're going to talk this last part right here, we'll talk about that more as we get into section 3.3. But the main thing is plotting the points correctly. Now, the other thing that's in this section, and I'm only going to do one example on the pre-video because we're going to do the other two in class. These are two formulas that you need to memorize. I'm going to talk about them here, but we'll talk about them again in class. The distance formula and the midpoint formula. So when you're trying to find the distance between two different ordered pairs, you're trying to find the shortest straight line between them. And the reason that this formula is the way it is, I'm going to draw you a picture right here. So if I have, let's say, this is a point, and let's say this is a point. And let's call this A and B just to distinguish them. If you want to find the distance between A and B, you would go in a straight line from A to B. Another way of thinking about this direction, though, is if we could only travel horizontally and vertically. If we could only travel horizontally and vertically, it's like driving in a city. You'd have to go 2 blocks this way, and then you'd have to go 4 blocks up. Now, that doesn't give you this distance. It actually gives you more because you've gone along the long way. But because this is a right angle, this forms a right triangle. And in right triangles, you can find this length right here called the hypotenuse by using Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. To solve for c, which is the hypotenuse, you take the square root. Now normally we would write plus or minus over here, but because this is a distance, we do not want a negative case. Distance is supposed to be positive. And to see, this is where this formula comes from. The reason there's these parentheses is because a, this distance a right here, and this distance b, they come from talking about how far did this distance change, okay? And in fact, some people might call A this one and B this one, but I'm just trying to keep it simple here. This is saying this had a difference of 2. You find that by saying this is 3 and this is 1, and you subtract them related to the x-axis. So that's why we're subtracting our x's and then squaring it. Same thing for the y distance. You subtract the y's and then square them. So that's where this formula comes from. So it's subtraction inside the parentheses. Squared is like squaring the sides of the legs of the triangle, and the plus is adding those two pieces together. So that's the distance formula. Midpoint formula is just finding the middle of that segment from A to B. To do that, you just want to average the coordinates. So you add the x's together and you cut it in half. That is taking just the two things, the starting x and the ending x. You say what's halfway. So you add them and you cut it in half. Same thing for the y's. You take the first y and the second y for the two ordered pairs, you add them and cut them in half. Notice in midpoint there's no subtraction in the original formula. If you are dealing with negative numbers, it sometimes could turn into subtraction, but the original formula should be set up with addition. And so this is just saying what we just said. It's an average of each. Now we're only going to do one of these on the pre-video because I'm trying to keep this short today. And then, like I said, we'll do the other two in class. So the directions say find the distance from A to B and then find the midpoint. So we're doing both things. So I like to label these. This is x1, y1, x2, y2. And then let's start out with the distance formula. This just says what are the 2 points we're measuring the distance of. So it's the square root of, we subtract the x's, so -2 minus 4 squared plus, now we subtract the y's, -5 minus 6. I could have done this just as easily the other way. I could have done negative 2, or excuse me, 4 minus a negative 2 and 6 minus a negative 5. Those would have both turned into addition, but the overall thing here is that as long as they come out to the same value after we square, it's still the same answer. So this is negative 6 squared plus negative 11 squared. Negative 6 squared is 36. Negative 11 squared is 121. And that gives us 157 underneath. So square root of 157, we do need to check and see if that has anything that goes into it. So 157 is not divisible by 2, not divisible by 3. It's because you're not going to know if it's prime or not just staring at it. Not divisible by 4. Notice as I divide, this gets smaller and smaller. 5, not divisible by 5. See, I went from having a 39.25 to a 31.4. 157 divided by 6. That's 26.16, so not divisible by 7. Nope. By 8. Nope. See how the gap is getting closer together? I know I'm done testing for things that could go into it as soon as I can break this down, and this is going to be smaller than what I divided by. So we're just kind of going through to make sure, because you should always double check so you don't miss points for not reducing. We know it's not divisible by 10. Let's try 11. That's 14 point something, so not divisible by 12. And I think this will be my last round, because as soon as I divide by 13, I get a smaller part for the answer. And notice nothing went in evenly. It was all a bunch of decimals. So this is reduced. Okay, so for that one, that's the distance. For the midpoint, we take our x's and we add them together, and then we cut that in half, comma. We take the y's, we add them together, we cut it in half. This is 2 over 2 and 1 over 2. So this would be a 1 when we reduce and a half. Do not turn it into a decimal. So that would be my midpoint. And that is all. So very short pre-video today.